So in this video, we're going to talk about balancing chemical equations, okay? And I always tell people, balancing chemical equations are not hard. We just need to know the difference between coefficients and subscripts and how do they work. So let's take a look at the first one. Okay, I usually read chemical equations from left to right. And so if I take a look at this, well, I have 1 mole of SN here, I have 1 mole of SN here. So those are balanced. So let's go to the oxygen now. I have 2 moles of oxygen, I have 1 mole of oxygen. And so I need 2 moles of oxygen over here since I have 2 over here. Okay, so if I put my 2 moles of oxygen there, then now look, this 2 not only applies to my oxygen, but it applies to this hydrogen here. And so you could see that I have actually whenever you have coefficients in front, they actually multiply, okay? You do not add, you multiply. And so in fact, 2 times 4 is 4, 2 times 2 is 4. And so in fact, I have now 4 moles of hydrogen on the right-hand side of the equation. And I have 2 over here. So to balance that, I simply need to put a 2 here. Okay, and this will constitute a balanced chemical equation. Now, what about the next one? Well, starting from potassium, I have 1 mole of potassium here. I have 3 moles of potassium here. And so if I put a 3 here, well, now that gives me 3 moles of potassium, but it also gives me 3 moles of oxygen, 3 moles of hydrogen, okay? So now that our potassiums are balanced, let's look at the next element. So oxygen, now we have 3 moles of oxygen, but look, we also have 4 here, okay? So 3 plus 4 is 7 moles of oxygen. Here we have 4 moles of oxygen plus 1, which will give us 5, okay? But remember, we have 7 over here and we have what? 5 over here, so that's not balanced. So in fact, if I put a 3 here, now look, that gives me 3 moles of oxygen plus 4, so that's 7. I have 4 moles of oxygen plus 3 times 1, which will give me 7. So now my oxygens are actually balanced. Okay. Now what about hydrogens? Well, notice here now I have 3 moles of hydrogen plus 3, so that will give me 6. Okay. Here, 3 times 2 is 6, so actually my hydrogens end up being balanced also. Well, phosphorus, again, we have 1 here, we have 1 here, okay, and that's constitute a balanced chemical equation, okay? So let's take a look at the next one. We're reading from left to right. I notice that I have 1 mole of potassium here. I have 2 moles of potassium here, okay? And so in that said, I'm going to put my 2 here because I need to balance potassium, okay? Now let's take a look at the next element. Okay, we have nitrogen. Now this 2 multiplies across, so we have actually 2 moles of nitrogen here. Okay, and over here we have 1. Okay, so over here we have 1, and so with that being said, because we need 2 moles of nitrogen, I'm going to put a big 2 in front of this here. And now look, my nitrogen are balanced. I have 2 moles of nitrogen now, and I have 2 moles of nitrogen. Okay, now what about oxygen? Well, 2 times 3 happens to be 6, so we have 6 moles of oxygen here, plus 3, which would be 9 moles of oxygen. Here, we have 3 moles of oxygen, okay, and 2 times 3 is 6, so we have 6 moles of oxygen, so that will give us 9, so that's also happens to be balanced. Okay, and if we take a look now, what about the hydrogens? Well, we have 2 moles of hydrogen here, and we have 2 moles of hydrogen here. So this constitutes a balanced chemical equation. Now, what about this one? Well, if I look over here, I have 1 mole of silver. I have 2 moles of silver. And so if I put a 2 in front of silver, okay, now I have 2 moles of silver. My silver balanced. Okay, let's take a look at the next one. Now I have iodine, okay. I have 2 moles of iodine because this 2 multiplies not only the silver, but iodine as well. So I have 2 moles of iodine. Okay, over here I have 1 mole of iodine. Okay, and so that being said, I need to attach a 2 here. Okay, and now this will be balanced, right? Because if I take a look, I have 2 moles of silver, 2 moles of silver, 2 moles of iodine, 2 moles of iodine, 2 moles of sodium, 2 moles of sodium, 1 mole of silver, 1 mole of, not silver, sulfur, 1 mole of sulfur, 1 mole of sulfur. So this constitutes a balanced chemical equation. Okay, let's take a look at the next one. Well, if I take a look at this, I have 3 moles of barium. Okay, well, how many moles of barium do I have here? I actually have 1. Okay, so I have 3 moles of barium. I have 3 moles of barium here. I have 1 mole here. And so, if I put a 3 here, well, notice that now my bariums are actually balanced. Okay, so I have 3 moles of barium here. I have 3 moles of barium here. Let's go to the next atom. We have nitrogen. Okay, we have 2 moles of nitrogen here. We have what? 1 mole of nitrogen here. Okay, so again, if we have 2 moles of nitrogen here and 1 mole here, I need to put a 2 here. Okay, and so if I take a look, now my nitrogens are balanced. Remember, barium are balanced, or nitrogen, we have 2 moles of nitrogen. Now we have 2 moles of nitrogen here, so that's cool. Now let's take a look at hydrogen. Well, it looks to me that I have 2 moles of hydrogen here. And I have 2 times 3, which is 6. So I have 6 moles of hydrogen here. So how does that work? So we want to be careful now, okay? So take a look at this. I have 2 moles of hydrogen here. I have 2 times 3, which is 6 hydrogens. Now, if remember, this 2 here multiplies to the oxygen and hydrogen. So in fact, I have 2 times 3, which is 6. And I have 2 times oxygen and hydrogen. So that will give me a total of 8 hydrogens, okay? And so if that is true, if that gives me a total of, well, actually, let's revisit. Let's think about it again. We have 2 times 3, which is 6. And then we have 2 times 3, which is 6 also. Okay, so let me be very clear on this one. Okay, we notice that we have 2 hydrogens over here. We have 2 times 3, which is 6. Okay, but this 3 multiplies across. And so if I take a look at the subscript, I have 2 oxygen and hydrogen, but this 3 is going to be multiplied by this 2 here. And so I have 3 times 2, which is 6, plus 6. Okay, so in fact, I have 12 hydrogens on this side. Okay, and so if that is true, well, 2 times 6 happens to be 12 also. So now my hydrogens are actually balanced. Okay, and now look at my oxygen. Well, I have 6 oxygens over here, and look, 3 times 2 happens to be 6, so that will give me 6 oxygens also. So this is a balanced chemical equation, so be careful. Now what about this one? Well, it looks to me as if I have 3 moles of calcium here. I have 1 mole of calcium here. And so I need to put a 3 in front of this. Okay. So that being said, now my calcium are balanced. So let's take a look at chlorine. Well, I have 3 times 2, which is 6. So that will give me 6 moles of chlorine. Okay. Over here, I have only 1 mole of chlorine. And so I need to put a 6 here. Okay. So now my chlorines are balanced. Now what about sodium? Well, I have 3 moles of sodium here. I have 6 moles of sodium here. Okay, so if I have 6 moles of sodium here and 3 moles of sodium here, I simply put a 2 here. Well, 2 times 3 happens to be 6. So that will balance my sodium. Okay, now what about phosphorus? Well, 2 times this whole thing. So in fact, I have 2 moles of phosphorus here. And then look, PO4 is actually being multiplied 2 times. So in fact, I have 2 moles of phosphorus here. Okay, O4 times 2. So in fact, I have 8 oxygens here. Okay, and over here I have 2 times 4, which happens to be 8 also. So this is a balanced chemical equation. Now what about the last one? Okay, well, it looks to me as if I have 1 mole of iron. I have 2 moles of iron. Okay, so I have 2 moles of iron. So, well, notice that now if I actually put 2 in front of this, well, if I put, hypothetically speaking, if I put a 2 in front of iron here, okay, and I put a 2 in front of iron here, well, notice that there's no way to balance this, okay, because that will give me 4 moles of iron. And then let's I was reading too much into this, but let's do it the traditional way. Okay, if I put 2 moles of iron in front of this, I don't think it will actually work. Okay, and so what I'm gonna do is I'm gonna put 2 moles of iron here. So that will give me 2 times 2, which is 4 moles of iron. Okay, and so if I put a 4 here, that will give me 4 moles of iron and 4 moles of iron. Okay, now this will give me 4 moles of sulfur as well, and then I still have 1 mole of sulfur here. So if I put a 4 here, okay, that will give me 4 moles of sulfur, 4 moles of sulfur, 4 moles of iron, 4 moles of iron. Now look at my oxygen. Okay, I have 2 oxygens over here. I have 2 times 3, which is 6. Okay, so I have 2 times 3, which is 6, plus 4 times 2. So we have 8 plus 6, which happens to be 14 oxygens over here. Well, 2 times 7 also happens to be 14. Okay, and so this is the balanced chemical equation. So this one is actually not straightforward, and so I had to see that. Okay, so some of them are actually not straightforward, and so we can't notice that most of these problems I've been reading from left to right, but in fact this case, and you could try it yourself, what if you put it, say for example you put a 2 in front of iron? Okay, do it yourself, you will see that it will not work. And so some of these equations are not straightforward like this one, not straightforward like this one, but again, you could see that these are nothing hard. The challenging ones are being able to see that this 2 actually is being multiplied by all of this. Okay, and so this serves as a nice practice for balancing chemical equations.